Hi students, welcome to today's class. In the previous class, I have explained what is differentiability of a function at a point x is equal to a. Simply speaking, differentiability of a function means, once again I am telling, of a function x and y. It is a, let us take y is equal to f of x. Let us take y is equal to f of x is a curve. Okay, now let us take a point x is equal to a. X is equal to a. So, what is the differentiability of this function at a point x is equal to a means what? A, this is f of a. That means if you are able to draw a tangent at this point, if you are able to draw a tangent at this point, this is a tangent. Understand, if you are able to draw a unique tangent at a point a comma f of a, then we say that the function is differentiable at x is equal to a. If you are unable to draw the tangent at that point, we can say that that is non-differentiable, not differentiable. Understand this? Okay. That means what? Differentiability speaks about the smoothness of the curve. Smoothness of the curve. If the curve is smooth and continuous, then at each and every point we can draw the tangents. Each and every point we can draw the tangent. Here we can draw the tangent, here we can draw the tangent, we can draw the tangent. So, to have a differentiability at a point x is equal to a, we should have left hand side derivative and right hand side derivative. That means what? F dash of a plus should be equal to f dash of a minus. So, both left hand side derivative and right hand side derivative should be equal. So, this is nothing but limit h tends to 0, f of x plus h minus f of x by h, and this should be equal to limit h tends to 0. It means x is equal to means you can put a, no problem here, f of a. This is equal to f of a minus h minus f of a by minus h. So, if you are able to show that these two values are equal, given a function y is equal to f of x at x is equal to a, then the function is differentiable at a comma f of a. That means we can draw the function. So, we can draw a tangent at the point a comma f of a. Now, let us see, let us focus our attention on in which situations the function is not differentiable. In which situations the function is not differentiable. In what are the cases that leads to the non-differentiability of a function. That means we are unable to draw the tangent. We are unable to draw a tangent, a unique tangent at that point x is equal to a. So, let us see the different cases of non-differentiability. Okay, now let us continue the topic. Let us see the non-differentiability of a function at a point x is equal to a. So, we have three cases. We have three cases. The first case is, so this is the first case. That means what? I will draw a graph and I will show you. So, this is a x axis and it is a y axis. Okay. There is a function, it is a, so this is a y is equal to f of x function. At x is equal to a, at x is equal to a, it is not it is discontinuous. At x is equal to a, the function is discontinuous. Therefore, we cannot draw a tangent at x is equal to a. That means if x at x is equal to a, if f of x is discontinuous, it is not discontinuous, then at x is equal to a, f of x is not differentiable, That means what? If it is any breakage is there, then how can you draw a tangent at that point? We cannot draw. That is why for differentiability, continuity is must. First thing is it should be continuous at that point x is equal to a. Here the function is not continuous, therefore there is a break. Then how can you draw a tangent at that point? So we cannot draw a tangent at that point. Therefore the function is not differentiable at x is equal to a. Let us take the second case. Let us take the second case. So at x is equal to a, given a function y is equal to f of x, f dash of a exists, f dash of a plus a minus exists. That means both right hand side derivative exist, left hand side derivative exist, both exist, they will get the values, but f dash of a plus is not equal to f dash of a minus. Both left hand side derivatives, right hand side derivatives not equal at x is equal to a. In this case, I will draw a diagram. X is equal to x and x axis. So in this case, we will have a sharp edge here. So this is equal to x is equal to a. So this is a left hand side derivative, a right hand side derivative, both exist but they are not equal. So at x is equal to a, we will have a sharp edge here. We will have a sharp edge. There you cannot draw a unique tangent. You cannot draw a unique tangent. So in this situation also, the function, so the function is not differentiable at x is equal to a. Understand? So this is the second case. Let us take a third case. What is the third case means here? Third case, at x is equal to a, both, that means both are either f dash of a plus f dash of a minus are infinite. Both are infinite or either one of the function is infinite. So that means what? If you find out the derivative at x is equal to a, the answer is infinity. If you get a infinity for both left hand side limit and right hand side limit or any one of the left hand side and right hand side limit, then also the function is not differentiable at x is equal to a. So in this case, how the graph will be? Let us see the graph. So this is a x axis and a y axis. In this case, the graph will be like this. At x is equal to a, so this is a x is equal to a, x is equal to a. So we have vertical tangent. We call it as a vertical tangent. So in which case the vertical tangent will come? So the vertical tangent will come, for that means what? For this graph it is a tangent, for this one it is a tangent. So if you find out f dash of a plus and f dash of a minus, so either or both are infinite. Infinite you should get, not finite. Finite means what? This exist and have a finite, exist and should have a finite value, and exist and should have a finite value. Not only simply existing, but it should have finite value. Finite value means what? 5, 6, 30, root 2, root 5, 7 by 8, like that. One particular value you have to get, minus root 2, minus root 5, like that. It both should not be equal, but here limits exist and but they should be infinite. So either of the limits are infinite, then at that particular point x is equal to a, we have a vertical tangent. Hence we can say that the function is not differentiable at x is equal to a. So these are the three cases where the function is not differentiable. The first case is discontinued. If at x is equal to a, if the function is f of x is discontinuous, if it is a break is there, then also the function is not differentiable at x is equal to a. That means what? We cannot draw a tangent. If there is a break, how can we draw a tangent? We cannot draw a tangent. That is the first case. Second case, the left hand side derivative exists and the right hand side derivatives also exist. Both are finite, but they are not equal. If they are not equal, then we will get a sharp edge. If there is a sharp edges are there, at the edge, those points we cannot able to draw the tangents. Therefore, at x is equal to a also, we cannot draw a unique tangent, we cannot draw. Understand that? That's why. So at this situation also, in this case also, the function is not differentiable. But the third case is at x is equal to a, f dash of a and f dash of minus a. Find out either both or either any one of the derivative value is infinity, then also the function is not differentiable at x is equal to a. At that point we will have a vertical tangent. We call tangent. So you may ask one doubt, sir, at x is equal to a it is intersecting, no, then how can we call it as a tangent? Means, but here the case is, here the right hand side derivative and if the left hand side derivative they are infinity, that's why we call it as a vertical tangent. Okay, now so I hope that you understand these three cases. So let us see, at a point we have seen that the function is a differentiable or not differentiable. If it in an interval, how to say a function is differentiable in the whole interval, how to check. So in the continuity also we explained continuity at a point x is equal to a and continuity in an interval. Here also I have so far we have seen the differentiability or non-differentiability at a point x is equal to a. Now we are going to see the differentiability and non-differentiability in an interval. Okay, now so let us continue the topic. Welcome to this concept, differentiability in an interval. Differentiability in an interval. So far we have seen that differentiability at a point. So we are going to see differentiability in an interval. Let us take this x-axis and it is a y-axis. Okay, let us take this is a function y is equal to f of x. It is a y is equal to f of x. Therefore, let us take x is equal to a and it is x is equal to b. Now we are going to check the differentiability of the function in this interval. That means closed interval. So we are going to check the differentiability of this function a and b. The first thing is, the first condition is y is equal to f of x should be continuous, in the interval a comma b. See here, open bracket a comma b. So at exactly x is equal to a and x is equal to b, there is no need of any continuity. So at x is equal to a, we cannot define the at x is equal to where end point of these intervals, we cannot define the continuity. Okay, now at x is equal to and x is equal to b, there is no need of any continuity. But in a and b, the open interval a and b, it should be continuous and the function should be differentiable. So y is equal to f of x should be differentiable at each and every point of open bracket a comma b. At each and every point of open bracket a comma b. See here, observe here, we are not in the both the cases, we are not taking closed interval. We are taking open interval. That means what? For a differentiability, we won't bother about this end points. X is equal to a, x is equal to b. We cannot concentrate on that end points. We will concentrate on the intermediate values. So intermediate means what? Middle values. This values. Not x is equal to a, x is equal to a, don't bother. X is equal to b, don't bother. Understand this. So if it is a open bracket a comma b, first should be, it should be continuous. Second one, at each and every point, differentiable and each and every point of a comma b, then on the whole we will conclude that the function is differentiable in the open closed interval a comma b. Understand? Very simple concept. Okay, now so let us continue our topic. Welcome to take a small problem based on the problems that we have, based on the concepts that we have discussed. Discuss the differentiability of the function f of x is equal to, the function is defined as when x not equal to 0, the function takes the value sin x square by x. When x is equal to 0, the function f of x takes all the constants 0. Okay, now at x is equal to 0. So at x is equal to 0, we have to discuss the differentiability of this function. That means what? This is a x axis, y axis. X is equal to 0 means what? Origin. At x is equal to 0, okay, now we don't know, but x is equal to 0. So here at x is equal to 0. So we have to discuss the differentiability of the function. That means what? If you draw the graph, we don't know the graph, we have to check whether it is that means we are able to draw a graph tangent at the point x is equal to 0. But we cannot draw the graph for this attached lines. But we will go approach this not practical with, theoretically we will approach. So at x is equal to 0, first of all we have to check the continuity of the function. First of all, it should be continuous. Let us check the continuity of the function. Solution. First thing what we have to do, continuity at x is equal to 0. At continuity at x is equal to 0. Let us check the continuity at x is equal to 0. To check the continuity, so we have limit x tends to 0. F of x is equal to f of 0 we should have. Already f of 0 value is equal to how much? F of 0 value is equal to 0. Okay, now 0. So let us find out limit x tends to 0. Limit x tends to 0, f of x. F of x means how much? Sin x square by x. Okay, now limit x tends to 0, sin x square by x. So this can be written as a limit x tends to 0, sin x square by x square into x. Multiply the numerator denominator with x. We can multiply, no problem. Why? Because here x value approaches to 0. Here no need to find out left hand side limit, right hand side limit. Why? Because for LHL and RHL the function is defined as same. Okay, now so this is equal to limit x tends to 0, sin x square by x square into limit x tends to 0 into x. Limit x tends to 0, sin x square by x square value is equal to how much? 1. Limit x tends to 0, x is equal to how much? 0. That is equal to 0. Therefore, limit x tends to 0, f of x is equal to 0. Therefore, the curve, the function, the curve is continuous at x is equal to 0. So let us check the differentiability. So differentiability means what? We have to check left hand side limit is equal to right hand side derivative. Left hand side derivative is equal to right hand side derivative. Next, what is that? Differentiability at x is equal to 0. Differentiability at x is equal to 0. First we have checked continuity at x is equal to 0. Next, differentiability at x is equal to 0. So let us find out the right hand side derivative or HD, that is f dash of 0 minus. First I will write down a minus a plus formula I will write down. So the formula is limit h tends to 0, limit h tends to 0. So this is equal to f of limit h tends to 0, f of a plus h minus f of a by h. Limit h tends to 0, f of a plus h minus f of a by h. So this is equal to f dash of 0 plus, that means limit h tends to 0, f of, in place of a, at where we have to checking a, x is equal to 0, that means x is equal to a. In place of a, substitute 0, so f of h minus f of 0 by h. Okay, now so this is equal to limit h tends to 0. F of h means how much? F of h means, so this is equal to sin x h square by h minus f of 0 value is equal to how much? 0. F of 0 value is equal to 0 divided by h. Okay, now so this is equal to how much? Limit h tends to 0, sin h square by h square, its value is equal to 1. So right hand side derivative value is 1. Let us find out left hand side derivative. Left hand side derivative, that is LHD. Let LHD means what? F dash of a minus, f dash of a minus. The formula is limit h tends to 0, f of a minus h minus f of a by minus h. Here a is equal to 0. Where you are checking? X is equal to 0. Understand? So that is equal to limit h tends to 0, f of minus h minus f of 0 by minus h. Okay now. Limit h tends to 0, f of minus h. So f of minus h means what? Limit h tends to 0. F of minus h means wherever x is there, substitute minus h. So this is equal to sin h square by minus h whole divided by minus h. So limit h tends to 0, sin h square by h square. This value is also 1. Minus into minus plus. Okay now. So that means what? Left hand side derivative is equal to 1. Right hand side derivative is also 1. LHD is equal to RHD. And moreover it is continuous at x is equal to 0. Therefore the function is differentiable at x is equal to 0. That means we can draw a unique tangent at x is equal to 0 for this curve. Okay now. So very nice problem this is. I hope that you understand this solution. Let us see one more problem. Welcome to this problem. Discuss the differentiability of f of x is equal to 2x minus 5 whole to the power of 3 by 5 at x is equal to 5 by 2. Okay now, right. At x is equal to 5 by 2. So if you draw the graph, at x is equal to 5 by 2. So we have to check whether it is differentiable or not. So we don't know that. We have to check this differentiable. That means whether we are able to draw a tangent at that or not. So to first of all we have to check the continuity of the function at x is equal to pi by 2. So first of all continuity of f of x at x is equal to 5 by 2. At x is equal to 5 by 2. Okay now, continuity of f of x at x is equal to pi by 2. So clearly see here, limit x tends to 5 by 2 f of x. How much? Limit x tends to pi by 2. So 2x minus 5 whole to the power of 3 by 5 is equal to how much? Wherever x is there, substitute pi by 2. So here 5 by 2, 2 to cancel, we are getting 0. So what is f of pi by 2 value? 5 by 2. So 2 into 5 by 2 minus 5 whole to the power of 3, 5. This is also 0. So from this what you got? So therefore limit x tends to 0, f of x is equal to f of 0 we got. Therefore the function is continuous at x is equal to pi by 2. Let us check the differentiability. That means able to draw a tangent at x is equal to 5 by 2. Differentiability at x is equal to 5 by 2. Let us find out the right hand side derivative. That means f dash of 5 by 2 plus. So what the formula we have? Limit h tends to 0. For example, if it is a f of a plus h minus f of a by h. That is the formula we have. Here a means how much? 5 by 2. So this is equal to limit h tends to 0, f of 5 by 2 plus h minus f of 5 by 2 whole divided by h. Okay now, right. Let us find out this value. So limit h tends to 0, f of 5 by 2 plus means what? So wherever x is there, in place of x substitute 5 by 2 plus h. That means what? 2 into 5 by 2 plus h minus 5 whole to the power of 3 by 5 minus f of 5 by 2 is equal to how much? Wherever x is there, substitute 5 by 2. 5 by 2, 2 will cancel, 0 you will get. F of 5 by 2 is 0. Whole divided by h. That means limit h tends to 0. See here, multiply inside, 2 into 2 will cancel, 5 will remain, 5 minus 5 will cancel, 2h remains. Therefore, 2h whole to the power of 3 by 5 by h will get. 2 to the power of 3 by 5 is a constant, take it outside. 2 to the power of 3 by 5 into limit h tends to 0, h to the power of 3 by 5 by h. So 2 to the power of 3 by 5 by limit h tends to 0 by 1 by this is equal to how much? So this is a 3 by 5 minus 1 minus 2 by 5. So this is equal to h to the power of 2 by 5. See here has h value approaches to 0. See here h to the power it is in the denominator. So this tends to infinity. That means here the limit does not exist. So f dash of 5 by 2 plus does not exist. Limit does not exist means what? So at x is equal to 5 by 2, this curve has a vertical tangent. That means what? So this is the graph of the curve. This is the vertical tangent we have. Therefore, it is not differentiable at x is equal to 5 by 2. So the function is not differentiable at x is equal to 5 by 2. So it will have a vertical tangent, not other tangent. Okay. So either, no need to check f dash of 5 by 2 minus, no need to check the left hand side derivative. So either, we already discussed the theory part, either of the limits or derivatives, right hand side derivative or left hand side derivative or both does not exist. If it tends to infinity, then there will be a vertical tangent at that point. Therefore, it is not differentiable at that point. Okay, now. So I hope that you enjoyed today's class with some more very important problems which are useful for your JEE mains examinations. I will come tomorrow, and until then, all the best.